Hello everyone, welcome to lecture number 8, and in this lecture we are going to talk about connecting LANs, backbone networks and virtual LANs. You may know that the local area networks, they are not isolated, so that means they can be connected to another local area network or they may be connected to the internet. So in order to establish this connection, we need to use some devices which are called connecting devices, which connect those different LANs together, or they are connecting the LANs to the internet or stuff like that. And each of these connecting device operates in a different layer of the internet module. For example, some of them may operate in the physical layer only, and another one may operate in physical layer and data link layer or stuff like that. So in this section, we are going to talk about the connecting devices, and we are going to divide them into five different categories. Based on what? Based on that layer in which they operate in the network. For example, some of them are working in a layer, and while another one is working in another layer or stuff like that. So in the next slide in this figure, we are going to find out some of them. So those five categories: one, two, three, four, five. So the first one, those which operate below the physical layer. As you see, here we have the physical layer and we've got the passive hub. And this passive hub operates below the physical layer. And we have a repeater or hub or active hub. And this active hub operates in the physical layer, as you can see here. And then we have bridges, and those bridges, or we've got two layer switches as well. So they are working in both data link layer and the physical layer. Routers or three layer switches are working in the network layer, data link layer, and physical layer. However, the gateway, which is in the fifth category, and it works in the all the five layers of the TCP/IP protocol internet model. So the first category is the passive hubs, and sometimes they are called T connectors. So it's just a connector, and it works under the physical layer, and it connects the wires coming from different branches. That means all the cables which are coming from the different computers are going to be connected to this connector, and it's just like the star topology. So it's a point where the signals comes from the different horses are going to be collided. So the hub is going to be called the collision point. So the second category is called a repeater, and a repeater is a device that operates only in the physical layer. So it can operate is only inside the physical layer. So it is a device that regenerates the signal. For example, when this one wants to send data to that host, so the signal comes over a physical distance. So the signal may become very weak here, and it may be totally attenuated in the receiver. So at this point, when the signal becomes weak, a repeater is going to be placed is there in order to regenerate the original signal or the original bit pattern. So this signal here is going to be the same signal there. So a repeater can extend the physical length of a LAN. So this LAN may can only send data up to this point, but we can place a repeater there in order to regenerate the original signal. So this is how a repeater works in a local area network. So to conclude the repeaters, a repeater connects segments of LAN. That means it connects a LAN to another LAN. So it connects a part of a LAN to another part of a LAN. So the length of a cable which is used here is limited up to 500 meters. In order to extend this length, we can divide this into segments, and we can install a repeater between those segments. And then we can say the repeater acts as a 2 point node. That means it has only two ports or 2 points. When a signal comes from one point, it's going to be generated or regenerated in the second point in order to be sent further. So a signal may come from a sender and is going to be corrupted here or attenuated. So after this signal going through the repeater is going to be regenerated to the original signal. So this is the right to left transmission, and this is left to right transmission, which are they are the same because you've placed a repeater in between the signal before, after it's corrupted or before corrupted. So the third category is the active hubs. So an active hub is actually a multiple repeater. So that means it works as a repeater and even it works as a hub. But in this active hub, the signal is going to be regenerated inside the hub. So inside the hub, the signal is going to be regenerated, and this is the most usefulness of this hub is in order to connect the LANs together, or connect a LAN or connect some LANs together. That means this computer can work with that computer or can send or receive data to or from that computer using this hub. But even this one can communicate with that one using that hub as well. So the third category is bridge. So a bridge is working in both physical and the data link layer. So we know that the passive hubs works under the physical layer, while the repeaters are working, or the repeater and the active hubs are working in the physical layer, and the bridges are working in the physical and the data link layer. So in each layer it has its own function. As the physical layer, it regenerates the signal, so it's like working like a repeater. But in the data link layer, it recognizes the MAC address of the source and the destination. We know that in the data link layer, the MAC address is going to be recognized, or it's going to be used in order to communicate between the hosts. So the bridges can recognize the MAC address of the source and the destination is going to be recognized for filtering decision in order to send that data to that receiver or not, based on the destination which is placed in the header of the message which is sent by the receiver, sender. And even though the bridge have filtering capability, that means it can check the destination address of a frame and decide if the frame should be forwarded or dropped. That means it recognizes whether this message has been sent to that particular receiver or not. If it is sent to that one, so it's going to be forwarded, otherwise it's going to be dropped. So this decision is going to be made based on something which is called a table that maps address to ports. So inside a bridge, there's a table which is used in order to make the filtering decision. Like here, for example, the this address, this MAC address, and that one belongs to port number one. So as you can see there, but those two are belonging to port number two. So through this table, it can recognize to where the data is going to be delivered. So the bridge filtering table can be classified into two main types. They are static table and dynamic table. First, let's have a look on the static table. So it is a very old method and it's not practical. So the table is going to be written or configured statically. That means the system administrator would manually enter each table entry during the bridge setup. That means that MAC address to that port, that one to that port, that one to that port. So anything, the process was simple as it's written here, but it was not practical. Why? Because if anything is changed, the change must be made manually as well. The system administrator must add to it. So every time they must monitor the system, and if a new device comes to the system, they must install it or introduce it to the system. And sometimes the MAC address of a host may change. So even in this case, the system and the administrator or the system administrator must change the configuration. And the second type is the dynamic table. So in this type, the addresses are going to be mapped to specific ports automatically, and this is going to be driven through a learning process. So the bridge is going to be learned automatically based on the movement of the frames. So if you have a look here, for example, if first time the host A is going to send a data through the D, so A is going to send the data to D. So it must send through the port one. So A is going, the first time the table originally is going to be empty, but in the first frame sending or frame forwarding, the A is going to be assigned to port 1. In the second one, E is going to send to A. E is here, it's going to send to A. It must send through 3, so E is going to be assigned to 3. And B to C. B here to C, and B is going to be assigned to 1 as well. So this is going to be the learning process of the dynamic table in the base. So we can say two-layer switches, which is shown there, are considered as a bridge, but they are going to have, more layers, because the bridges with few ports can connect only few lines together, while a two-layer switch, which is this one, is going to work as the same as the bridge, but it has more ports, and even it makes the filtering decision based on the MAC address, and it's going to assign each MAC address to a specific port. So, but the difference is that this switch has more ports than the bridge. So the fourth category is routers. So a router is a three-layer device that routes packets which are inside the network layer. So that means the routers are working over the network layer, data link layer, and the physical layer. So they are working on their logical addresses. That means it works, or it sends the data based on the logical addresses. That means the IP addresses or host-to-host addresses. So the routers are normally connecting the LANs and WANs in the internet. That means when you are inside your home and your mobile device or your computer is connected to your modem, and this is a LAN. This LAN is connected to the internet. So this is being done by using the routers based on something inside the routers, which is called a routing table, and it's going to be configured in order to make a decision where to send the data, or where the data is going to be received, or in which host the data is going to be shown. So the routing tables are normally dynamic. That means that table which is inside the router is dynamic, and they are always updated using the routing protocols. So this is a very important picture of the router. This is a router, and that's a router, and that is a router, and we can say this is a router as well. So the routers are connecting independent LANs and the ones as well. So this router is going to be connecting that LAN and that one together, and even it's going to connect those three LANs to one, to the wide area network or to the internet, and even that router connects that LAN to the wide to another one, and this router is connecting that LAN to the rest of the internet or to another one or anything like that. So the fifth category is gateway, and the gateway is just like a computer, a normal computer or a host that operates in all the five layers in the TCP/IP Internet Protocol, and the seven layers of the OSI model. Okay, so that means the gateways are working over the whole layers of the internet models. So just like an application. So there is a message inside an application. It's going to be read, and then it's going to be interpreted or encrypted, or it's going to be sent through the entire network to the destination. So through the gateway, a network which is based on the TCP/IP can communicate to another network which is based on the OSI model. So those two different networks can be connected together using the gateways. And here is a new subject which we are going to talk about, the backbone network. So a backbone network is the network that allows several LANs to be connected together. So multiple LANs can be connected together using a backbone network. And all the node station, so not only a single host is directly connected to the backbone. So the computers inside the LAN are not directly connected to the backbone. They are connected to the LAN, then the backbone connected to the LAN together. So there are so many different architectures to be used for a backbone, but we are going to cover only the bus backbone and the star backbone. So the bus backbone, in this backbone network, the topology is going to be a bus. So So any protocol can be used which supports the bus topology. And an example of this one, when we are connecting a network using inside a building which has some floors, or they are inside the camp. So each single floor is going to be a LAN. So each multiple floor has a backbone. So usually it's going to be a star topology which connects those LANs belongs to each individual floor together. So a bus backbone is going to be connecting those LANs together as a backbone. So we can say a long cable is going to be a bus backbone here, which is it's going to be the main cable that links all the devices in the network. So you can see it in the next slide, which is this one. So we have a line, and we have a LAN, and we have a LAN and LAN, and they are going to be connected using a bridge to the bus backbone. This is going to be the bus backbone. As you can see, for example, this LAN may be connected uh, to that bridge, and through that bridge is going to be connected to the backbone. This is what is called the bus backbone. So in the star backbone, or sometimes called collapsed or switched backbone, the topology of the backbone is a star. That means we are going to use star topology or in order to implement a star backbone. So the backbone is going to be only a switch. It's not a cable like the one we use in the bus backbone. So it's going to be called it's going to be called erroneously or collapsed backbone, and that connects the LANs together. So that's why it's going to be those terminologies are going to be used, because the backbone is just a switch. And here we have the backbone, which is a switch, and this is a LAN, another LAN, another LAN. This may be a star topology or a bus topology or stuff like that, but by the end of the day they are all connected to a backbone, which is a switch, and this is called a star backbone. So connecting a remote LAN. So it is going to be a good application or an important application of the backbone network that connects remote LANs. When you say remote LANs, that means connecting through the internet, or they are far from each other. So this type of backbone is very useful when, for example, an organization or a company has several offices, which each of them has its own LAN, and the company needs to connect all of them together. So this connection is going to be done using bridge. So sometimes they are called remote bridge, and this bridge acts as a communication device which connects those lines together, as such as ISDL, least telephone lines, or the point-to-point link can use a protocol such as PPP. So this protocol used in order to establish this communication is called PPP. Here we have an example. We have a LAN and a LAN and a LAN. They are all remote LANs. So using the remote bridge, using the point-to-point ADSL line, those LANs could be connected. And let's talk about the virtual LANs. And we can say that the virtual LANs, or virtual local area networks, are local area networks, but they are configured by software, not only by physical cabling or stuff like that, physical connection among the hosts which are connected within a line. So in this figure, we can see that it's an engineering firm that 10 horses or 10 stations are connected together using a LAN. So, but they are grouped into three different groups: Group One, Group Two, Group Three. So this is an example. So we are going to cover this example using the virtual local area network. So, but we can see that all of them are connected together using a switch. So belongs to the previous slide, which is this one. What happens if, for example, the administrator wants to move two engineers or two horses from this group to that group in order to make the works done by this group faster? So the administrator or the network engineer must rewire, or must do everything from scratch, must disconnect the wires there and connect the wires over there. So this is going to be time consuming, and it must, and sometimes maybe cost consuming. So instead of using physical connection, we can say in the virtual local area network, we are going to use logical segments or instead of physical segments. So in this figure, it's just like the previous example, but we are going to use the virtual LAN. So we are going to divide the stations into subgroups. So each group is going to be called a VLAN. For example, this is VLAN 1, which is composed of those four engineers, and those three engineers belong to the VLAN group, and so on for the third VLAN group. So in this way, whenever, for example, this engineer wants to be sent to that group to the VLAN one, it's going to be done easily because it is a software configuration, it's not a hardware configuration. And this is going to be, a logical group. This is a logical group, another logical group, and another logical group. So any member or any engineer in each group will receive the same message that broadcasted from another VLAN. For example, this VLAN, an engineer from this VLAN sends a message to that VLAN. If the message is broadcasting message, is going to be received by the whole members or the whole engineers in that VLAN. So we can say that moving members from one group to another through software is easier than changing the configuration of the physical network, or disconnecting and then reconnecting the cables. So and even in the virtual local area network, we can connect two switches together, for example, and this LAN, this physical LAN may be somewhere, and that may be somewhere else. But in the virtual local area network, we can group different members from different switches together in a VLAN. So that one with those three, which is belonging to that switch, is going to be in the same VLAN group. So how to define the membership? So what do you mean by membership? How do you define that? For example, this one, or in this example, that one and that one and that one are going to be in the VLAN one, or those three are going to be in VLAN 3, while they are all connected to the same switch. And for this example as well. So the membership can be defined using some characteristics, which are port number, MAC address, IP address, and multicast address, or a combination. So a combination of two or more of them. So whenever we refer to the port number, we say that NIST can define the station connecting to port 1, 2, 3, and 7 belong to VLAN 1. For example, in this one, port this is port 1, 2, 3, 4, 5, 6, 7, 8, and stuff like that. So for example, port 1, 2, and 3 are going to belong into the VLAN 3, and for example, those ports are going to belong to the VLAN 1, and the other ports are going to belong to VLAN 2, or stuff like that. So you can define a VLAN based on the port number, and using the MAC addresses can also be a membership in order to group some hosts together or some members together. For example, using the MAC address, for example, if a computer has that MAC address and that one, or that one, or sorry, not that one, or those two, or any other we can add to it, are going to belong to a VLAN or particular VLAN. And even for the IP address, any computer that has that IP address and that one and that one and that one are going to belong to a particular VLAN. And even you can use a combination of those things. So, for example, we say that IP address and that one. So that means the computer must have that IP address and that MAC address. Or you can say that MAC address and that port number. The computer must have that MAC address and connect it to that port. So here is an example. Create a system of three LANs with four bridges. The bridges are B1 to B4. So the connection of the LANs are going to be as follows. B1, bridge 1 connects LAN 1 and LAN 2. So this is B1. So it connects that LAN and that LAN, which are LAN 1 and LAN 2. B2 connects LAN 1 and LAN 3. B3 connects LAN 2 and LAN 3. LAN 2 and LAN 3. B4 connects LAN 1, LAN 2, and LAN 3. So this is how you can configure a network.